All right, all right. What's up? What's up? Welcome to this week's Q&A live session for my algebra clients and my math clients. I want to basically do a spiral review on a few different mathematic equation solving techniques, show you a few examples that you might be seeing if you're taking my Algebra Made Simple 10-week course. But really, this is helpful stuff as far as standardized testing examples. So if you ever plan to go to college or something after high school, you're probably going to have to take some sort of college entrance exam. A lot of people take the ACT where I'm from, but ACT, SAT, it really doesn't matter most of the time. But when you want to go to go to grad school. I mean, anytime you're moving up a level, a lot of times there's some sort of standardized test benchmark that you want to get used to taking, get familiar with, because there's opportunities not only to get into the school of your choice, but also to usually get scholarship dollars. So that's a big incentive for most families. So anyway, let's go ahead and get into it. So I want to talk about a few different examples that you're going to see if you're specifically taking my critical thinking portion of the Algebra Made Simple curriculum. And so one of the questions that pops up, I mean, some of these you're going to be familiar with. Some of them we didn't outright teach, but I want to give you the thinking skills, the critical thinking skills. The one of the biggest thing that I could hopefully leave you with after our time together is the ability and the exercise almost in your mind to actually ask the right questions, go through logical, train of thought so you can arrive at different conclusions. So the first one I want to look at is a situation that's called literal equations. If you ever look them up on Google or if you're trying to find similar problems, where basically you have equations and none of them are coefficients or constants. You don't have any numbers. They're all variables. They're all letters, right? And so the instructions for one of them said to solve for R. I'm going to write this down on my board and then I'm going to put it up on the board so you can see it really clearly. And it says A equals P plus PRT. A equals P plus PRT. And you're being asked to basically rearrange the equation and solve it for R. And so you want to ask yourself, what are the operations happening, occurring, and what would be the inverse? Remember, whenever we solve equations in general, you're basically doing order of operations backwards. Order of operations is PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. Well, if you've noticed the pattern with a lot of equations, you're going the opposite direction. You add or subtract first, then you multiply or divide, and so on and so forth. You're actually doing order of operations backwards. So when I say backwards, I'm basically referring to an inverse operation. So here's the first one I'm talking about. If you have an equation, this is called a literal equation in a lot of math curriculum, okay? But they're asking you to solve for R. My handwriting's not great, but that's what that says. That says for R. What that means is we want the equation to get rearranged and say R equals everything else instead of what it is right now, which A is equal to everything else. A equals P plus PRT. We don't want it to be A equals. We want it to be R equals. Okay. And so that means I look at the side of the equation that has the R. Which side has the R? Is it the left side or the right side? Oh, it's over here. It's on the right. See, the R is on the right side. And everybody who's not R has got to go. You got to go. I mean, you got to think like an introvert. Introverts are like, you know what? It's been nice. I enjoyed the party. Time for you to go home. Okay. Don't hit yourself on the way out. So right here, the P's got to go over here. The other P's got to, the T, everything that's not the R's got to go. Well, how do you do it usually? If it wasn't a letter, you'd know what to do. A lot of you guys who've had me, you know that anything added to the part that's being multiplied usually has to go first. That's a positive P. So I'm going to minus P on both sides, right? And so A minus P, we don't really know what A or P is. So only thing you could do is write it as A minus P, and then you'd have PRT on the other side. Okay. Since we don't know what A or P is, you can't actually combine them together. They're not the same term. There's an A, there's a P. So if you minus P to one side and move it to the other side, it doesn't tell us anywhere, P equals this or anything. Then all you can do is just write it as an expression A minus P. But you still have things that have to go. In other words, you got a P, a T. Well, they're all being multiplied together. If you see PRT, it sounds like Michael Jackson. PYT, pretty young thing. Well, this is PRT. Okay, I don't know. Just made me think of that. But PRT really means P times R times T. They're all being multiplied together. PRT. Okay, I'm done. How do you undo multiplication? All right. The opposite or the inverse, right, of multiplication. I'll give you a second. Ding, ding, ding. Hopefully you said division. Yes, it is. So I'll give you a little trick. If you got two variables, P and T, they're all being multiplied. This is saying P times R times T. If you don't want to, if you want to save some time, you can actually divide them both at the same time. Just give me a little trick. So what I'm going to do is I'm going to divide, because that's the inverse. I'm going to divide P and T, PT, away from the R. See what I'm saying? What you do to one side, you have to do to the other side. So PT. We do the same thing to both sides. Well, what's that going to do for me? That's going to cancel out the P's on that side. It'll cancel out the T's on that side. Ding, 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 leaving me with just the R. Okay, so I'm running out of room here, but the new equation would look like this. Okay, I'm just going to circle it because I'm running out of room. It would be R equals A minus P over PT. A minus P over PT. I can't do anything else. I can't cancel out the P's because I would have to factor that away. A minus P is kind of considered like an entity. It's almost like husband and wife. They're married. They're a package deal. Until I separate them, I can't really cancel anything out. So this is as far as I could go, and we have solved it for R. It's called a literal equation. And so it's something that you see if you go through a traditional algebra course, both in Algebra 1 and Algebra 2. And sometimes they throw some in pre-algebra. But I will also say it's a very valuable skill for your sciences because you have so many formulas and you can kind of rearrange them. You know, if distance equals rate times time, for example, you can divide, rate and time and, redo that equation for, the rate. If distance equals rate times time, that means, well, rate equals distance divided by t, So you can rearrange things by doing inverse operations. So rewind this if you missed that. I know I kind of did it quickly. But I just want to give you little tools for how you could, attack some of these questions, I guess. Okay. So another one that I noticed from here that I wanted to look at was something called, everyone's probably seen this if you've been in middle school. And I'll be so surprised if you took the ACT or the SAT and they didn't have something on scientific notation. Okay. So it says write the answer in proper scientific notation. Scientific notation is probably something you learned about in 7th or 8th grade in most situations. Probably by even 7th grade, you've probably seen it. But what they'll do is they'll make it look like scientific notation. And you're going to have to notice the differences. For example, I'm going to give you a quick recap on what scientific notation is. I could have the number 2,500, right? And if I wanted to rewrite it in what's called scientific notation, you take first non-zero numbers like 2 and 5, and you're supposed to put a decimal between those two, 2.5. And instead of having 0, 0, what you do is you say times 10, and you got to ask yourself, well, if I had a decimal between the first two numbers, 2 and 5 here, how many times would I have to move it to the right for it to get on the other side of that last 0, right? I have to move it 1, 2, looks like 3 times. So scientific notation of 2,500 would be 2.5 times 10 to the power of 3 because I had to move the decimal place 3 times. You see that? So that's a quick recap on how you rewrite anything in scientific notation. All right. Now, let's say it wasn't a whole number like 2,500. Okay. I'll get rid of those humps so it doesn't look weird. Okay. Let's say it was like a decimal because sometimes they'll give you typical whole numbers, 515, 48, things like that. And then sometimes they give you partial numbers called decimals, right? Where you might have something where it's like 0.0023 and they want you to write that in scientific notation. Daddy's working right now, baby. So you got to wait. No, go back to mommy. Sorry, my little daughter found me. I'm recording live. She doesn't know that. Okay. But listen, this can be in scientific notation too, but you have to go the other way. In other words, to go from where the first two non-zero numbers are, which is right here, to where the decimal is here, you'd have to go 1, 2, 3 places, but to the left. So in scientific notation, you'd say 2.3 times 10 to the power of -3. Okay. Even if you wrote that out in the calculator and multiplied it out, you'd get 0.0023. So bottom line is if you're going left, it's negative. If you're going right, it's clearly positive. And that's basically scientific notation. Now, here's where they get kids on these, where they can trick kids if you're not being careful because they anticipate people not noticing this. One of the questions on your assignment was 7 times 10 to the power of, let's see, what was it? To the power of 5, I think it was, times 3 times 10 to the power of 4. I just want to make sure I wrote that down right, all right? I'm going to put it in parentheses just so it doesn't look too confusing. And then it says, please write this in proper scientific notation form. Okay, write it in proper scientific notation form. Well, first off, you need to realize you got these whole numbers, 7 times 3. You need to multiply those out. 7 times 3 is 21, right? And then if you've ever paid attention to properties of exponents, when you multiply the same base that has different powers, you can just keep the base and add them up. 5 plus 4 is 9. And so that would be my first step. And a lot of people are going to be tempted to think, right? You're going to be tempted to think that this is in proper scientific notation form, but it is not. Why? Because technically, even though you don't see it, 21 means that it's 21.0, right? The decimal would be on the right of the 1. For it to be in scientific notation, the decimal would have to be on the other side. So proper scientific notation would have to be, between the 2 and the 1. So what they'll do is they'll have an answer choice or two, and they'll have plenty where it's 21, times 10 to the power, and you think that's the answer in scientific notation. Well, no, the decimal in proper scientific notation always has to go between the first two non-zero numbers, such as what I have here. Well, what does that do to my answer? Well, that's going to affect my answer, if that makes sense. If this is 21 times 10 to the power 9, and I had to move it back 1, I actually have to go further to get back where this was. So in other words, this would have to go up 1 and be 2.1 to the power of 10, okay? Because there's an extra space I have to move it if I'm not starting from here and I'm having to start from here. I have to go, oh, there's an extra one. Now I go 9 more, right? So that's a total of 10 moves, if that makes sense. Very, 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 very sneaky type of question, but they like to be sneaky, When it comes to college entrances, it depends on the school, of course, but, some places just want to whittle it down to a few, right? It's kind of hard to get into the school, and so they'll have these kind of gotcha questions to see if you catch that or not, all right? So that's another one. Just wanted to throw up there. Probably going to be on the ACT or SAT because scientific notation is like a concept that you see, probably starting as early as middle school. Some of these questions involve factoring. And so, if you spent some time with me in my Algebra Made Simple course, you should know how to factor if there are 3 terms, 1, 2, 3. Like, for example, I see 1 on here. I'm just going to mention this. It's 5x squared minus 3x minus 2, 3 terms. Well, because there's a 5 in front of the x squared, if you've taken my course, we called it the AC method of factoring, where you try to split it into 4 terms and factor by grouping. So that happens on one of your questions, actually a couple of them here. And so just kind of keep that in mind. Another one I want to look at, and this is maybe a reminder because we did cover this to some degree, is a property of exponents. So anytime you multiply like bases, the rule is you have to add the powers. But if you have the opposite, sometimes you're dividing like bases. Let me write this one down real quick. It's x squared. I want to show you an example. X squared times y to the power of 6 times z to the power of 3. That's a z, all over x squared times y squared. Okay. I have to look at that to make sure I got it right before I put it up. Okay. Can you see that? All right. So check this out. You have right here, basically, you could call it a rational expression. Essentially, it's a fraction. It's a fraction. You got a numerator, you got a denominator, right? You got x squared, y to the 6th, z to the 3rd over. This is division. I've always said this. If you've ever taken my classes, fractions are really just division problems in another form. In other words, this top numerator section is technically being divided by what's at the bottom. And so if you've paid attention or had a lesson on the property of exponents, whenever you have the same base, and when I say base, it's the thing being raised to a power, so x squared over x squared. If you got the same thing over the same thing like that, you can keep the base and subtract the powers. 2 minus 2 would be 0, so that would leave us with x to the power 0. But if you paid attention to the property of exponents, anything to the power 0 really equals 1. So this right here are reduced to 1. And it makes sense because anything over itself equals 1 anyway. 5 over 5 equals 1. 10 over 10 equals 1. X squared over x squared equals 1. So no matter how you look at it, you're going to get 1 there. So for our purposes, I'm just going to cancel out the x's because that's going to equal 1. Let's move on. If you look right here, you got y to the power 6 over y to the power 2. See, the y's are the same. We match them up. If you have the same base, keep the base. 6 minus 2 is really 4. So when you're dividing the same base, you keep the base, subtract the powers. 6 minus 2 is 4. So that's what we would do with the y's. And then z to the power 3, there's not another z down there. So I'm just going to keep it in my answer. Okay. So there would be my answer. Y to the 4th times z to the 3rd. Okay. So I'm not trying to, go do all the examples for you. I just wanted to throw up a few reminders, a few ways of looking at it, thinking, maybe draw some of the lessons from the past to your memory. Okay. So that you can kind of feel a little more confident as you're going through this. Remember, you either get the answer right or you learn. Okay. If you can keep that mindset, you don't really ever lose. You either get it right or you learn. Okay. So learning is the key. If you miss it, who cares? Just pay attention to what you did and see if you can figure out why and try to make improvements on the next time. All right. That's how we really open up a future to ourselves. So anyway, that's all I got to say on this one. I'm going to go ahead and wrap it on up, but this is your quick Q&A live. Watch this thing, view it, rewind it if you need to, and then do the work. The best way to learn the math is to do the math. And I'm here to help. All right. Y'all have a good one. I'll catch you on the next one. Peace.